Yes, the best paper of the year, for the record, MLBBQ, where we don't present. Uh, yeah, more opinions if we not record it. But we can always pause the recording if we start going controversial. So if people who are watching online, if you see a strange jump, that means it was something really interesting that you're missing. But here, if you feel like you want to say something inappropriate, let me know first. I will put it on pause. Pavel has his first exit full screen. No, it's kidding.
It should be gone.
Okay.
So I decided to choose the Muon paper. It's technically not this year's paper, but there was some deviation covered by Mike. And so Muon optimizer is an optimizer for machine learning deep learning model stadium, which is setting one constraint, which is like to make the updates in such a way that the activations do not change too much. Like how can we make updates to the model in some way that is smooth to the activations. And this problem is solved by SVD decomposition of the gradient, I think, and normalization of its singular values. So it's like a spectral normalization.
Yeah, you dealt with spectral normalization this whole year.
It's dedicated to MLPs.
Oh yeah.
Yeah, right?
Yeah, I think intriguing thing about it is that Muon optimizer changes the direction of the gradient a little. It doesn't just scale it. And so in the end, you are getting different kinds of updates to your weights, and it seems like it's more robust in terms of changing many weights instead of just single little subset.
Interesting. Too bad Brad is sick and he's not here because in our work with him, or he showed a lot of findings, like simple in retrospect, but not obvious, that the gradient updates are always low rank just by construction. They're low rank because they're outer product updates and things like that. So the gradient itself is low rank. So whatever you're affecting, the subspace that you are actually heating is low rank. So does Muon make it? Yeah.
Laura.
Yeah. Is it low rank? Okay, well, anyways, good. Okay, well, we'll go with that. But Muon, okay, next time, or can you do while others are showing this? Can you put a link to the paper? Like actually, link to the paper because we can come back, and some people may want to read the paper who have not read the papers. Yes, Selim has the link to the paper.
Yes. Yes. 25 to 50% of domestic abuse cases involve alcohol. So that's something we need to address, and I think it's not addressed enough at all. So I was looking at papers that address alcohol addiction or how it affects our inhibitions. And in this paper, they are addressing one part of the brain that controls, like, let's call them green light, red light, when you're making decisions. Like the D1 MSN, or there is the green light, D2 MSN, the red light. When you take alcohol, the ability of saying no to some decisions, which are controlled by D2 MSN, they get affected badly. So the red light in your traffic intersection doesn't work properly. So these guys are looking at like what to address about that. Before the signal goes to the D2 MSN, there's the green part, dorsomedial striatum, which includes cholinergic interneurons. And they found that these cholinergic interneurons, which used to be considered a secondary modulator, were actually a causal bottleneck. So yeah, one sentence point of this paper is what used to be taught as secondary is actually a primary thing to address. So how do they address it in the paper? They do it at the subject level. But I don't know like how that can be done in every case. So maybe a good idea to develop is find some medicine drug or maybe something that you can insert into the beer, wine, or the alcoholic beverage we are selling at the stores to do what they did at circuit level, so that you still get the taste and all the pleasure you get from drinking alcohol, but you don't become a less person.
Well, but maybe the point of alcohol is actually to remove the social barrier.
But a result of that is an increase in violence, especially inside your home. So if the point is to lower these inhibitions, then we should remove that from entirely.
Well, I don't know. Anyone has thoughts because I have a couple parallel lines. One line is Alonka was telling me I didn't know before that because not all of the genetic makeups like of people like not all people have alcohol. What is it called? Alcohol. The enzymes that break up alcohol, basically, the metabolite alcohol. They sell those enzymes, turns out, like a little bottle for $10, and it actually works.
Okay, and are people buying them?
Well, I don't know, but that's another point. Another point is that I read somewhere, like South Korea did not achieve as much as it deserves in terms of how hard people work, etc., etc. And it's a paradox. Why not? And their culture is super, super, super regulated. It's so strict that for them, when they do a startup, they do not speak in Korean inside of the startup. They speak in English and they use different English names for each other because the social norms are so complicated. They stall the progress. Basically, if somebody's like, if somebody is a little older than you use very different language with them and they always right and blah, 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 all that stuff. And so with the alcohol removing, like, I think like if social structure is super strict, and I'm not talking about home domestic abuse and things like that, but maybe it's an alternative. I mean, it's a fringe theory of mine. Maybe there is a reason of balancing out. Like I know in Russia they used to fist fight like the entire village. Everyone would just like for fun. Everyone fist fight. Yeah, like bosses, like all that social hierarchy, and then you forget it. And then after that, nobody holds a grudge. Like
when you
that's
say
it.
everybody fixed fights, is that all men and women?
No, only men. Only.
Yeah. If it was only men, I'm still okay with it, right? I can fist fight you and forget about it tomorrow. But if I'm fist fighting my wife, if you're fist fighting your wife, that's not okay at all, right?
But that is not the point of prohibiting outlawing fist fighting.
Okay, so we sometimes call something that
It's just like, well, if a person gets aggressive when they drink alcohol, well, they shouldn't drink, or drink it in a different environment, right?
yeah.
It's a social problem.
It's a social problem, and also the social problem in the sense self-control is like know thyself, right?
Yeah. We normalize that.
It's like why would you even drink? Like why are you trying to make drinking easier? What's the point? It's like if it doesn't work for this person, just say okay, don't sell them alcohol. There are
How are you gonna start?
we have abusers, we have legal system for that, right? People who abusing like child abuse people are marked on Google Maps. You see where they live and things like that. So don't sell them alcohol.
Okay.
Or
if you can do that, if that can be implemented,
no, we have LLMs and surveillance.
Well, even before we also have KYC forms. When you buy gold, you also have to show your ID. When you buy alcohol, you also have to show your ID. Just take the ID check for the alcohol.
yeah.
A bit more than just I see the ID. Okay.
No, but it's weird. I mean, both of the solutions are weird, kind of absurd.
Yeah.
It's like it's full total control over society. Just, I hope is viewed as absurd, but maybe not by some. But, or, oh, let's make alcohol actually good for you, or this is also weird.
That's what people do in Vietnam.
Full control, or
No. We're making alcohol better. The put like roots inside of alcohol. Like, yeah, this is medicinal. This will help my liver. Let me drink this 45-degree alcohol.
Whatever chemical in the alcohol that won't harm the person in any way, but still somehow make these decision-making parts of the
I know what it is. Sedative. Make them sleep.
Yeah, sure.
Just cut the alcohol with melatonin.
Yeah. And then they can start harming.
Yeah, if it works, that's fine.
No, that's all right. But this is interesting. The mechanism interesting. The premise is weird.
And I, my one criticism is like this is the most important figure, and this is the 17th figure in their supplement. This should be in the paper and in a in an easier to understand image.
Well, maybe you're not the intended audience. Thanks.
I do refresh the I have the link. Okay. My favorite paper this year is Alpha Math, Olympiad level of formal mathematics reasoning with reinforcement learning. That title is massively underselling what this paper achieved. This paper basically did near gold, but now gold, IMO level performance with an LM. And the way that it achieved this was by turning math into a video game, in the exact same way that Go was turned into a video game. Turning math into a video game has been substantially harder than Go, which was born as a video game. But now that math has been turned into a video game, we can hill climb. And so this paper is impressive not just because it turned math into a video game. It's not the first one to do that, but because of the novel approaches that they did specifically for Lean. That takes into account the nature of math as a video game. So they didn't just do RL. Everyone and their grandmothers these days can just like make a RL environment, have an LM, just like loop until you're done. But what they did was also they did tactic level fine tuning. They extracted everything in MathLib and then took all the information out, fine tuned on like the metadata inside of the math tactics. So the LLM doesn't just see text, it also sees a bunch of metadata. And they also did problem variant generation. So problem too hard, we'll make it easier. And then make it even easier than that. And then if it's kind of simpler.
How do they know the problem is too hard?
If it can't do it.
Oh, problem is too hard for you.
Amazing. Everything just falls out of the fact that math as a video game has very nice semantics. They also tuned the lead runtime to make it run 6 times faster. They also invented a new thing called inference time RL, where after you do RL in pre-training, at inference you can do a rollout, and if it gets stuck, do problem variant generation on the problem that it's doing at inference time, RL on that, and then revisit the problem afterwards. And so now it's like actually
So you change the weights.
You change the weights at inference time for that.
Well, I mean, you fine tune.
Yeah, I guess you fine tune, but like it's doing actual RL, it's doing the same RL that it was doing in proper RL, but this time directed at the problem that it's doing at inference time. This does mean though that individual problems on their paper cost thousands of dollars, but 45% of Putnam. 45% score on the Putnam.
Oh,
yeah. I don't know.
a human is 20.
So anyone here want to take a guess? It's out of 120. what the average score of the department, or what the median score of the department? Zero. No one gets anything. Yeah, it's insanely hard. It is the hardest math competition, basically, period, besides actually doing frontier math. And so as competition math is as hard as it goes, and it gets 45%, which is, I think, 97th to 98th percentile. So this paper produced an LLM that is better than probably all of us at math. And that's great. I hate math. And so we don't have to do it anymore.
That's a nice ending of the year.
Yeah, yeah. I hate software engineering. I hate math. I'm glad both of them have turned to video games and other stuff. I want to play better video games.
I need to digest
People aren't ready.
This is a hard truth.
People aren't ready for the fact that math is really easy. It's just the tooling sucks. The tooling in education for math just completely sucks. The fact that you can't do it, like you have a bicycle. You can learn to ride a bicycle by yourself. You pick up the bicycle and you can go, and you can, like, if you fall, you understand, oh, I'm doing it wrong, but do it right. Right? You don't want to go faster, you just go faster. If it doesn't actually do that, then we'll just fix your approach. But with math, if you're doing it on paper, you just write symbols and, like, how the hell do I know I'm doing anything correct? You don't. But if you have a mechanized,
No, you do. You check every check. That's
who would check? If you did it wrong, how would you do it, check it correctly?
That's why we have teachers.
No. Teachers annoy me. You check it because it's logic steps. You find the mistake.
I am Andrew Wiles. I wrote the proof for Fermat's last theorem. It is 80 pages long. It was incorrect multiple times.
Yeah.
Within. Yeah. Like it works fine for, like.
Well, if he spent another 20 years checking it, he would find those problems.
Do you know how easy it is, how fast it is to check Fermat's last theorem in Lean? It's like 500 milliseconds. It costs nothing.
Well, if you started writing, yeah.
Right. But
All I'm saying is that your statement is that math was from the beginning. You can check it. That's the point of math.
well, the thing is,
It's just hard, but it's because
no. The thing is, it's not possible at a lot of levels because the grammar that people use for describing math is not sound. Like if you think about math on paper as a language, like in the same way that you would treat a programming language, the grammar is not sound. It doesn't have a decidable parsing pattern.
No.
Right? It's undeterministic. It's non-deterministic how you parse that math. And it's largely by consensus in sociology that certain proofs are accepted. I believe that proof is true because, well, like anyone here actually gone through the proof of central limit theorem?
No, but we never go to the proofs. That's the point. It's like some people do, and it's fine, and we just rely on it.
But why would you do that?
Like you don't want to check every proof. It's just everyone checks every proof. The complexity goes exponentially, and what's the point?
But like I today can download the source code for the Linux kernel.
How many people here have ever compiled the Linux kernel? Everyone should have done that, right? Yeah, I don't know how many kernels have compiled, but even compiling, I mean, that's
Well, no, but in principle, it shouldn't cost, like, it took like 8 years to verify Fermat's last theorem.
yeah.
And only 17 people on the entire planet, every single person who could verify that proof, were on the committee, and they took them 8 years.
Yeah.
Insane. Like, imagine it took that long to, like, find one bug in a Linux kernel. In computer land, we have like fuzzers, we have tests, we have red teaming, we have like social norms around targeting vulnerabilities in software. And in math, it's just like, trust me, bro. It's like, oh yeah, we verified this 17 years ago. Oh, by the way, that proof was still not verified completely. When we're reporting it into Lean, we discovered new holes. And so it's not even done. For Vermont. Yeah, for every proof it's like this. Most proofs you chuck into Lean, and it's the same math. The math being done in MacLink is Bourbaki style ZFC. It's exactly the same thing. Not that line by line, except just expand it because sometimes this proof is this step is trivial, expands into 2000 lines.
Yeah.
Yeah, but now that it's actually a video game, this is the problem. I do this step. Okay, change the problem like that. I do the next step. And I do more steps, and then once I'm done, it verifies it, and I'm right. For the most part.
Okay, let's go because we have more and hopefully better papers than. So, it's and Sam, I don't know, Sam has not connected. Oh, oops. Yes, Sam. Sam is not here. Recent advances in Alzheimer's disease mechanisms clinical treatment.
Armina presented this paper.
Yes, I did. I'll take credit for it.
Oh, okay. Do you? But you obviously over that already, right? It's not the best paper of the year according to you.
It's not a best paper to me.
Okay, good. So people online who's watching it, and if you're interested in that paper, go to trendcenter.org and find the Reading Club. The video recording of Armin's presentation is there.
So I chose this paper, which is called More Brain, Routed Mixture of Experts for Interpretable, Generalizable, Cross-Subject fMRI Visual Decoding. I think this year I kind of became interested in like the mixture of expert stuff, so I found this paper to be kind of interesting twist on it. But it's actually from our group, and one of the authors is here. So I think this paper was accepted to NeurIPS in 2025 as a poster. And so I think this paper is interesting because they use these specialized experts to process signals from particular brain regions in this kind of like new hierarchical architecture. And so I don't know if we've had a paper like this released from our group before, but essentially this is doing this like decoding images from brain signals from fMRI. So I think that might be kind of like a hot research area now, especially with like BCIs and stuff like that. But yeah, I found this to be pretty cool. They also did an interpretability analysis where they kind of looked at how different experts were actually able to trace back which parts of the brain were responsible for like visual processing on different parts of the image and stuff. So I found this to be pretty cool. And it was having pretty good accuracy competing with some of the state-of-the-art methods like Mind2Eye and MindBridge. So yeah.
For the data collection, is it a block design paradigm or random images are shown? You know, remember? For data collection, are they showing the same block design, like the same type of image multiple times, and then another class of image multiple times with sort of reset in between, or it's just random images flashing? How do the subjects see the images?
Check this set. It's a I knew, because it's a long time. I don't remember the very details of the.
Yeah, like the data set.
Yeah, it's the set is public. It has a paired label from it. Let's say. I don't know how to use the word to express. It means that
Like, is it like the subjects are watching a movie?
yeah. It has many labels that the fMRI signal is the corresponding sound.
Oh, is it a movie data set? Is it like?
I think no.
It's called the natural scene.
Yeah, natural. Yeah, it's not a movie. It's just a video picture.
Yeah, but how do they show that? Are they showing like tree, and then pose, and then human?
It's a series of different kinds of images. Because here I see they're showing a horse, someone skiing, a pizza, baseball, and then yeah, I think.
Like block design, when they're showing the same thing multiple times, or this like similar, they cluster.
Oh, okay.
And then they don't like so your brain is saturated with just this type of response, and then nothing. So your brain desaturates, and then again another class block of stuff, and then like I don't know, or versus like random stuff that's showing.
Yeah, I'm not sure.
Okay, anyways, congratulations for the paper.
No, I know about you said the data, the content, but actually I don't understand the question, so you will just give me that. Sorry. I mean,
So we have experiment design, right?
yeah.
So the subject is in the scanner.
Um,
And what is experiment design? Is it a block design? Is it like random images, or like how are they demonstrated to the subject?
it's like, oh,
Yeah, let's go further to the next paper. Yeah. Okay. It's a standard question, standard terminology. Yes.
in the form of the paper, it has some heat maps that we just show.
No. This is not about your paper. This is about data.
Okay.
Yeah. The question is about data. How was this data collected?
Oh, you mean oh,
fMRI in subjects that see the
yeah. You mean the person that subject the person that see the different pictures, the view. The
Yeah.
view of
So
the picture
how is that
they
designed?
collect the fMRI signals and yeah, we decoding the fMRI signals to the picture for video decoding like this. And I just mentioned that they had some maps that they had every subject has show the different pictures that in the data set. The data is can download of the website. It's
Yeah.
not our.
This is not my question, but yes,
Oh,
thank
sorry.
you. Well, I need to look at the data set description, how they collect, what was the design of the study. Okay. Thank you, John.
I just remember it's only about the normal normal 20 subjects. It's very big because the collect this signals very hard.
Yes.
Very hard, yeah.
Okay. They're always doing Java.
So actually, I don't have a fast paper, but
Is that the worst?
no, definitely not. The question is like when your mom and the wife jump in the water, what do you say? No, I didn't have a choice, but what I'm doing is recently I'm doing kind of the self-required learning work, and I send this question to AI. And which one is the best SL algorithm this year?
Oh,
You
self-supervised.
have to give me result. And
Oh, so consensus is on this, basically.
yes, and then I saw the big name and the title and what they're trying to solve. I think reasonable.
Recipes, Facebook AI research, recipes.
Yeah. So for this, I haven't fully read this paper, but I know they're trying to solve this why the model learned representation works. But they are trying to explain it in case all the modeling, ball twins, momentum, local, all the stuff, they're learning the representations. They can do a lot of good downstream works, but same that they do not have explanation. I'm not very expert in this area, but same they don't have explain why it works well. But this paper is trying to explain that, and I haven't read it.
Too bad. Okay. According to which LLM, this is the best paper of the ChatGPT, Gemini, Llama.
Give me this, and I also searched on the Chinese social media, and some.
Do you have DeepSeek? If DeepSeek agrees that this is the best paper for you.
No, I did not. You think?
Okay, don't forget, we can't use DeepSeek.
Oh, okay, no, you did right.
Can't.
Yeah, yes.
What do you mean? It's against GSM policy.
It's my own laptop.
Okay.
Well, open it up. Use whatever you want. What's the fancy offers?
Well, for those online, we use organic American grown DeepSeek. Not that Chinese stuff.
Oh, I see. Two. My cross project.
Oh, they have too many papers.
Too many papers, right? Oh, wait, You have more than one? Oh, the entire list of papers from that Micron's project. Where is that Micron's project? It sounds like is we 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 had a talk about I forgot who gave it.
Is it one of the slides of brain?
Yeah, establishing those connections. Was it you gave that talk, right?
But it's on human brain.
Yeah, the 1 millimeter or something. This one is on human, that one was on mouse.
From a mouse.
Yeah.
And now 150 people study that. 1 cubic millimeter.
1 cubic millimeter, yeah. But this is yeah. This is like insane technical effort, right? To just get it processed. But yeah, I remember you. I remember you. So the question to everyone is this like, is it worth? Well, I mean, it's hard. I don't mean worthless, but worth the effort. I guess some things that were technically, physically very difficult at one point became very easy at another point. So at some point, this process will be very easy. Do we need to do it right now in order to make it later to become easy? Like we used to have logarithmic tables, right, where people like publish the values of the logarithms and stuff, and so they would actually calculate them and spend time, and that was valuable effort at the time. But then if we said, oh, let's not do it now, we will have computers in 200 years, and then they will do it for us. Maybe computers will come because we don't do it now. So there's kind of insane efforts like that. Are they enablement or are they just too early for their time?
And I think maybe they will get better this time, like less improve this time, because genetic sequencing was used to be very expensive. Now it's like you could do an entire human scan. Are they? Maybe less.
But yeah. But it's still expensive, but it's not like it's not like $1 million.
So yeah, maybe this is like a first step. It's expensive, but
so you think it's worth it? It's just like we should
sure.
iterate.
I guess it's worth for the method development. I'm not sure if
the data.
Well, we have some chats. Someone chatted in the Zoom.
No, there's nothing. It's I'm looking at the chats. It's TJ said something in the beginning about self-censorship because we are recording, but I don't think we're saying anything.
This is my vote. I think it's no surprise. eLemur, they did a 3D atlas of the mouse lemur brain, all of the kind of similar to what Thu presented, but just for mouse lemurs. And ever since finding that this was a thing, I've been super excited and trying to find a way to work with lemurs. So that's why it gets my vote as the paper of the year.
Yeah, maybe we'll have Minecraft for animals. That would be good. Not for lemurs, but for lemurs.
Yeah.
And this if it inspires you. Yeah, and I think Minecraft is a driver now, like the industrial strength model and regulations. Eating words. Okay. Oh, okay. TJ. Give it attention.
Yeah, so this paper, if people were watching or at NeurIPS this a couple weeks ago, won the Best Paper Award. It's from the Quinn team out of Alibaba. It was posted in May, but there was just a lot of publicity around this paper, and I thought since it won the Best Paper Award, we're going to see a lot of this in next year, so it's good to know about it going into the next year. especially since this has to do with more architecture related gated pieces, trying to train and upscale a lot of the LLM models. So really what they're trying to do is take this softmax attention gated issue and try to solve like what is important in intention. So instead of allocating all attention resources, they only allocate some and zero out non-important information and say they claim to solve hallucination. And that's fun and a big deal if you're trying to sell a product that's maybe ranked fourth in sort of the landscape of LLM. So with Alibaba coming out with this, they're hopefully gonna see bigger insights with different like I was looking it up. Quinn 3 Next is their next model that'll incorporate all of this coming out at the beginning of next year or something of that nature. So it'll be interesting to see if this actually improves or not, or it gets adopted by other companies as people continue to post different research. But I don't know. That's why I linked it here. I don't think it's the best paper this year, but it's going to be important going into next year.
Yeah, that's interesting. I looked at this paper. So I don't know, Alex, do you mean you haven't read Titans or you read Titans and haven't read Gated Self-Attention? Um, Alex posted online Titans. But what caught my eye in this paper is that they enforce practically they enforce the column structure of the alignment matrix. So they like, okay, this entire column will be selected, will be highlighted, and other columns will be suppressed. And interestingly, for the members of this group, is that what we already see in Mrinal's and Mike's work and stuff. So without additional gating. And so I wonder, but in parallel, this behavior by some people is associated with attention collapse, whatever that means. And so, like, they're encouraging attention collapse in a sense with this gated attention. So I'm not. Empirically, they show that it works, but it's a strange, over-engineered approach. Like, I don't see a system to the madness, sort of. Like,
Yeah, I completely agree. I mean, they even said it was trained on 3.5 trillion tokens, and I'm like, that's great. You spent all that money for that and all of the extra information to add all the pages to this report, even. But it
yeah. How much is a page? I never thought about that. I just
500 plus a page, a grand a page. Like, what is NeurIPS rates nowadays? Like, it's
I didn't
crazy.
know you can add a page. Like,
Yeah, no, and I've seen it in different conferences before too, but it's all from the larger companies trying to just get more information or their pretty graphs to like get publication headlines.
yeah. Like, this is insane. I didn't know it's possible. Okay, so
So anyway, not best paper, but important, and I just thought it would be fun to add.
thank you. Yeah, thank you for bringing it up. There were other interesting papers, but we'll talk about them at the end after going through all the slides. Maybe Alex, you want to talk about Titans? Extra. Oh, we already had extra. Everyone gave their slide. Oh, so there was an interesting paper that I think it's not the best, but still, since we went into kind of not the best, but notable papers already, and I spoke to them at their poster. So basically, we want distillation, right? We want a large model to train a small model to come up with an answer. So we want large LLM to teach a small LLM to solve mathematical problems, for example. How would you organize that? How would you teach the large model to be better teacher? So what they do is they give the large model the problem and the answer. And the goal is to produce a chain of thought that comes up with this answer from this problem. And then the small model is trained on this chain of thought and they kind of train end to end. Well, the obvious hack is for the large model is to just repeat the answer many times within the chain of thought. Just the answer. And so the most logical outcome for the small model will be the answer. It's like when you see complete the series, right? One, 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 one. What's the next one? 15? No, one, right? And so put the answer multiple times. So the small model with this chain of thought. Okay, you don't understand. So the large model gets the problem formulation and the answer and needs to fill in the gap. The small model gets the problem and this reasoning and should come up with the answer based on that reasoning of the teacher. So the teacher teaches the small model how to reason through. So but there is a obvious failure mode. What they do is now they add a laws that says scale divergence between the activations of the small model on that chain of thought should be similar to like the distribution of the activations of the small model should be similar. Yeah, fantastic.
Policy URL.
Yeah, it's just so simple. It's too bad that we cannot do that to our children. But maybe that's good.
You can.
No, like, you cannot scale divergence to be to think. To
What,
think
what do you think equity is for? That's what it does.
no, this faking machines. Children will fake it. It's just no. But then I thought, well, and they were complaining that, like, not complaining, but like, hey, look, we cannot teach children like that or humans. But I think it's good that we can't teach humans like that because all we should care is about outcome, not about the process. We should leave diversity of the process. We should let people, arrive to the solution their own way because then maybe we will not stay for 1,000 years in a local minimum like we did with Go and chess. Yeah, well, like Go and chess are good examples when they instilled in the culture the way to play, and we just recently changed out the Go and the Zero and stuff that learned that was local minimum. It wasn't the best way to play. Okay, that's all I have to say, and thanks everyone who came up with a slide. I thought you would have a slide. What is your base paper besides your paper?
Actually, I don't have best paper in my mind this year. I didn't read much more about the the current papers. I take the conference, I take conference, and I found that the 2 years the deep learning and the artificial intelligence technology is changing very fast. And actually, in the conference, more than 80, I think more than 98 papers I cannot understand what it looks like. I just tell the truth. So I in the conference, that I just been to join the news, and I recognize some my friends. They are very young. They are reading, pursuing the PhD degree, and I also learned some new technologies with them. And you just mentioned the language model LLM and VLM. I saw the many people they use the technologies. So I recently this week I also want to combine some new technology to solve some engineering tasks that. But I didn't. I just at the beginning for the new technologies. Yeah, I found that the traditional deep learning has. Uh, I don't know how to use the word to describe it. It's out of the scope that the new papers they don't use the traditional deep learning. They all use fine-tuning the large model like this all of them. So yeah,
because that's so human.
yeah, but so actually this year I didn't read much more papers. I just the coding. I just organize the task and writing the paper, submit the conference. Yeah, but from this conference, I just I mean I learn more about some technologies and currently the the current technologies. So I will transfer to use some new technology. Yeah, it's just the beginning. You know what I mean?
It's like with deep learning and machine learning, every year is just the beginning. It's just a fun field. So interesting. But then I saw two papers from the conference, from NERD's conference, that are interesting. One is related to Mike's interest, is where this group from Israel, they took mathematical constants, like 348 of them. Yeah, like they flowed all the mathematical publications that are available in digital form, and found all of the mathematical constants of different sorts. And they tried to find a system, like a polytope, like a topological representation, some space where all these constants make sense, that they derive from each other.
The same thing. It doesn't exist.
They could do it to 40% of that. They could unify like about 40% of those 300 constants. So the Platonic world is kind of closer and closer. Like we can touch. So that was an interesting one. And there was another one. This is just like not expected. There was a woman from DC was showing a poster on regulations on why we should have AI on automated drones. And her main argument, because AI hallucinates. So that's
Humans famous for not hallucinating.
yeah, exactly. And I tried to give her examples, and I don't know. Well, anyways, like there is a thing that is called just war theory, right? It's about when the war is actually just, right? When it's a good thing to do. Philosophers spend time on that, and so assuming the war is just, would you rather let humans go there and do their human thing, which was, or you'd rather have drones doing that? Stanislav Lem, the god of the linguists, like the Zeus, have already thought about that back in his day, and wrote a book about alternative world where superpowers decide their stuff on the moon, fully automated war. Drones of one superpower fight a war against drones. No humans are involved, all humans are on Earth, whatever, and whoever wins the match, or like it's an actual war, but it's fully automated.
Screw the moon, but we have the Pacific Ocean. No one goes there. Send drones in there and see how to do it out.
There is a lot of animal life. Let it be. It's
think about the moon germs.
The number of moon germs is like not like let's leave. Yeah, thanks, Alex. Alex put a poster into the this one. I don't know if screen share start like that.
What was her poster? The idea that we should have
prohibiting generative any form of weapon control.
There is no distinction between generative AI and anything else now.
Yeah,
it's all generative.
Yeah,
And
well,
anything predictive is generative.
Not really. What do you mean?
Anything predictive can be flipped around into a generator.
No,
I think it's the other way around. Make a generator.
Yeah, I think it's the other way around. So it's whatever you have to be. You need to be able to sample from, and not everything is like a progress distribution. Some things are just junk. Sure.
I know we didn't do this last year, but did we want to try voting on which paper was?
Oh, we didn't do it last year, but we did do before, and we had winners.
You want me? I made a little poll.
Oh, okay, let's do it. Let's do it, but let's make it offline, right? Because we have only 5 minutes. So do you want to make it online? Maybe online right now, the recording. We may not have time. How about in the channel, in the reading group channel? So TJ, please vote for a paper also. Yeah, and I think it was a fantastic year. I hope we can have many more. And let's get together in January for a planning meeting for the next semester and choose the papers, the wannabe best papers. Only choose those that you think have a chance to make it to the last to the last presentation of the year. and we will schedule sometimes first, second week of January, whatever is after the second. And again, thanks everyone being part of our discussion. Thanks to Jerry connecting from far away, and thanks Alex for connecting today. Yeah, we'll see you all next year. Have a good break.
Yeah.